Hello, my name's Amna. I'm a fourth-year nanotechnology engineering student, and today we're going to talk a little bit about nanotech engineering at the University of Waterloo. All right, so a little bit about me. I'm in my fourth year, so I've gone through 5 years living here in the city of Waterloo. Over these past few years, I've been involved in the engineering community quite a bit through engineering ambassadors. So those are people who speak with first years and grade 12 students just talking about engineering life and the different programs and giving tours around campus and just freshman experience, things like that. Over the course of these past few years, I've worked as a URA. That's an undergrad research assistant. So I got the chance to work with a prof on campus and work as an undergrad in their lab. It was a really cool lab. It was a bacteriophage lab, and they used microfluidics to study the growth and infection rates of bacteriophage, which was a lot of fun. I also worked as a marketing and design lead at WNC, and that's a Waterloo Nanotechnology Conference. Every single year, sometime in the fall term, we host many different professors and people from industry across North America to come to Waterloo and speak about their research, which is a really fun way to learn more about the field and also network and meet new people. And just Waterloo engineering experience means co-op, and co-op has been one of the best things that could have come out from these past 4 years. My most memorable student experience moment has been working in the lab. As a part of the nanotech program, we get a lot of hands-on experience. And during your third year, you get to work in the clean room and fabricate some MIS capacitors, which has been so much fun, such great experience. My number one tip for any engineering students starting off in first year is to make friends in your cohort. Your cohort is your built-in support system, and it's just the best way to succeed through your time at Waterloo. So I feel like I kind of touched on this, but what I really love about Waterloo and specifically the nanotech program is that, first of all, we're direct entry. So right away, you're in your cohort, you're with your people, and you're taking all the same classes together, you're in the same labs together, you're doing the same assignments together. And so you really lean on each other to get through the academics. And then you also just have a built-in friend group to just have fun around campus and through the city of Waterloo. The other thing that's really special about nanotech in particular is that there's so many hands-on lab experiences starting right from first year. You're doing chemistry labs, biology labs, electronics labs, and like I mentioned before, you get to work in the clean room, which is very fun. So that first picture up there is a little silicon wafer, and all those white dots, as small as they are, that's 200 nanometer diameter capacitors, and it's crazy, but I made those, and you may too if you come here as a nanotech student. And then right below there is everyone's favorite little lab during the nano program, making quantum dots. So I have 6 different types of quantum dots, all different colors. So that was a lot of fun. And then the other really cool thing about nano is that it's just so interdisciplinary. There's so many applications. Using nanomaterials and nanoparticles can be applied in many different fields, even more than you would have thought. I would not have thought that I could be doing what I'm doing now through my co-ops and eventually post-grad, but nano goes into fields of biomedicine, electronics, cosmetology, the food industry, energy storage, and so many more. Okay, so now we're going to talk a little bit more in depth about what exactly is nanotechnology engineering, a quick introduction about the university in general, what types of lab spaces we have, and then just the academic curriculum that will take you during your 4 years here. Okay. So the first thing to talk about is what exactly is the scale we're looking at when we say nanometers. 1 nanometer is 10 to the negative 9 meters. And so to put that into perspective, if we start on the left-hand side of the screen and we have hair, that's a strand of hair is about 100 nanometers. If you go all the way to the smaller side, you get a water molecule, which is 0.1 nanometers. And all the way in between, we have things like transistors, viruses, bacteria, human cells. And so this is kind of the scale of the things we're working with. Okay. So Nanotechnology at the University of Waterloo is a collaborative program. This means that we fall under two departments, both chemical engineering and electrical and computer engineering within the Faculty of Engineering, but we also get professors from outside of engineering too. Quite a lot of our professors are from chemistry, so science as well. And because of this, we get a really unique perspective from different profs, from different disciplines, and you can tailor your learning throughout your 4 years to very specific specialized areas such as nano-engineered materials, nanoelectronics, nanobiosystems, nano-instrumentations, and so much more. Okay, what exactly is nanotechnology engineering? It's an engineering that's at a very small scale but has really big impacts. It's a mix of science and engineering and the applications of various technologies conducted at the nanoscale. It is recognized by Professional Engineering Ontario, which means it's an accredited engineering program, and it's perfect program for students who have an interest in electrical and chemical engineering, chemistry, biology, physics, material science. Okay. So nanotechnology engineers, huge impacts, so many different fields. Some examples are up on the screen here. So working in biotech and making biosensors, something like the COVID-19 vaccine, drug delivery, medical imaging, that's kind of the biotech side of things. Also a lot of computation and numerical analysis. So that goes into software modeling of many different practical problems. Materials engineering is a big part of nano engineering. So that's things like that falls into fields such as construction and fabrics and cosmetology. There's big impacts in the energy sense sector. So things like batteries and photovoltaics. This also kind of branches into nano instrumentation, in which falls into electrical engineering. So things like semiconductors, integrated circuits, those really small circuits that kind of power everything nowadays. And lastly, optical engineering, which kind of falls into all of those sectors as well. Okay. So what exactly is nanotech engineering? If you think about your phone or your computer or even an Apple Watch, have you ever wondered how so much storage can be found on something so small in such a compact space? This is all done by using nanofabrication and nanomaterial processes to create the billions of tiny transistors that make up the ones and zeros that translate to computations and display data in our electronic devices. One important application of nanotech engineering is integrated circuits or chips, and these chips are essential for all the different devices we've come to depend on. As a part of the nanotech program, we have dedicated clean room and state-of-the-art labs for the undergrad students, one of which is the clean room. In the clean room, there's many different pieces of equipment and instruments that undergrad students can use. One such example is the PECVD, that's the plasma enhanced chemical vapor deposition, and the PVD, physical vapor deposition. These are instruments that can be used for thin film deposition. Thin film deposition is when you deposit a very thin coating of some material on a substrate, usually around the range of a few nanometers to 100 micrometers. And it can be very specific and is used in many different technologies. Other instruments that you might be able to use are the reactive ion etching or wet chemical etching. And so these also fall into nanofabrication techniques to etch away material and make specific patterns so that you can have the devices that you need. Some other equipment and instruments in the clean room, specifically in the yellow light room in the clean room, is the photolithography suite. Here we have photoresist spin coater. So this is to layer thin layers of material onto a wafer, for example. Photoresist baking units, mask aligners, UV-vis exposure tools to specifically expose either the resist or the substrate to make a specific pattern. And then solvent hoods for cleaning off the resist and getting desired patterns. And through this process, you can solidify and make very specific patterns that are then used to make our devices. Yeah. All right. So the academic path and what exactly are you going to be learning? So we have a list of the typical first-year courses that all 1A nano students will be taking, and then a list of the types of courses you can be taking in your upper years. In third and fourth years, you have a chance to be a little bit more specific and specialized in what you want to take, and you can pick exactly what courses and what type of streams you are interested in, which is really cool. This is kind of a graphic of what type of post-undergrad perspectives our students have. Quite a lot of us end up in industry, and quite a lot of us also end up in advanced studies, going into post-grad studies like getting their master's or a PhD. And then there's also a small percentage of us that end up starting startups and working in that community. And then this is a breakdown of the types of typical careers by sectors of where we end up. And as I mentioned before, there's so many different fields of where you could end up. Nanotech is a growing industry, and there's just more and more applications coming up with how you can use nanotech. Okay. So why nanotech at Waterloo? So in my very unbiased opinion, we have the best lab space and building on campus. The home of nanotechnology is the Mike and Ophelia Lazarus Quantum Nanocenter. Nanotech in general is a very unique program in Canada with all of our specialized lab spaces like the clean room and all the specialized courses we're taking from day one. There's about 500 nano students studying in the nanotech program right now, and our graduates end up in industry, go to professional and graduate schools, and form startup companies. Okay. If you have any questions, you can always chat with our engineering student ambassadors, and you can match up specifically a nanotech student and ask them any questions you have. If you have any admissions related questions, you can always contact enginfo@uwaterloo.ca, or you could book a tour and come to any of our open house events.